Hello viewers, in today's class we are going to discuss an important concept in three-dimensional geometry, right? So here we are going to discuss the concept of image of a point with respect to a plane, right? In our previous videos we have discussed a lot of problems related to three-dimensional geometry, in which we have also discussed the image of a point with respect to a line, right? But in this class we are going to discuss the image of a point in a plane, right? So let us start. So here we have the problem, find the image of the point 6 minus 5 minus 2 with respect to the plane, whose equation is given by vector r dot 2i cap minus 3j cap plus 4k cap plus 10 is equal to 0, right? So here we are given a point and the vector equation of the plane is also given, right? So now here let us first draw a rough diagram related to this problem. So here let us take a plane, and this is the plane, and we have a point, say this point is say P, and the coordinates are 6 comma minus 5 minus 2, right? And we have to draw we have to find the image of this point with respect to this plane, right? And here we should note that this plane acts as a mirror with respect to this point P, and the image, it lies below this plane, and let us say the image is point Q, whose coordinates are alpha, beta and gamma, right? So the image of this point P is this point Q, and we have to find the values of alpha, beta and gamma, right? Now here the equation of this plane P, we can also draw or we can also denote this plane by the letter pi, and here the equation of the plane pi is given by vector r dot 2i cap minus 3j cap plus 4k cap plus 10 is equal to 0. So now we can convert it into the Cartesian form. So vector r can be written as xi cap plus yj cap plus zk cap dot 2i cap minus 3j cap plus 4k cap plus 10 is equal to 0, and the dot product or the scalar product of these two vectors is given by x times 2, this is 2x, then we have minus 3y, then we have 4z plus 10 is equal to 0, right? So this is our plane, right? Okay, now from the equation of the plane we see that this equation is of the form ax plus by plus cz plus d is equal to 0. So this is the standard form of the Cartesian equation of a plane, and ABC denotes the direction ratios of the normal vector, right? So here the normal vector is this is the normal vector, and the direction ratios of this normal vector to this plane pi are given by a, b, c, which are the coefficients of x, y and z respectively, right? So dr's of the normal vector are given by 2, minus 3 and 4, right? And here we see that this line PQ is parallel to this normal, right? And we know that if two vectors are parallel or two lines are parallel, then their direction ratios are either equal or proportional, right? So here PQ is parallel to this normal vector. Therefore we can take the drs of this line PQ as these, right? So 2 minus 3 and 4 are also the drs of this line PQ, right? Because the PQ is parallel to this normal vector, right? Now here let us take a point M, and M lies on this plane pi, right? And PM is the perpendicular to this normal, that is PM is also parallel to this normal vector, right? And PM and normal vector are parallel, so the drs may be taken as same. And now let us first find out the equation of this line PQ, right? So equation of PQ can be written as x minus x1 over a, y minus y1 over b, z minus z1 over c, right? And x1, y1, z1 are the points through which this line PQ passes through. And here this point can be taken as x1, y1 and z1, right? So A, B, C are the direction ratios of this line PQ or PM, and we can take the direction ratios A, B, C as 2 minus 3 and 4, right? So the equation of this line PQ is given by x minus 6 over 2, then y plus 5, because here y1 is minus 5, so minus minus becomes plus, and we have minus 3, and z plus 2, because here we have minus 2, right? And here we have 4. So this is the equation of this line PQ. Okay, so now what we will do, we'll find the general coordinates of a point lying on this line PQ. So for this we can take a scalar lambda, and we can find out the coordinates of general point lying on this line PQ. So we have x minus 6 over 2 is equal to lambda, y plus 5 over minus 3 is equal to lambda, and z plus 2 over 4 is equal to lambda, right? And from here we have x is equal to 2 lambda plus 6, and y is equal to minus 3 lambda minus 5, and here we can take z is equal to 4 lambda minus 2, right? So now 2 lambda plus 6 comma minus 3 lambda minus 5 comma 4 lambda minus 2 represents a general point on this line PQ, and that general point may be taken as this point M, right? So now the coordinates of this point M may be taken as 2 lambda plus 6 comma minus 3 lambda minus 5 comma 4 lambda minus 2, right? Okay, so now here we see that this point M lies on the line PQ as well as on the plane pi, right? So therefore this point M, it satisfies the equation of the plane pi, because this point M lies on the plane also, right? So let us substitute the values of x, y and z in the equation of the plane pi to get the value of lambda. So now M lies on the plane, so therefore this point satisfies the equation of the plane pi, and now we have 2 times x. For x we can take 2 lambda plus 6, and minus 3. For y we can take minus 3 lambda minus 5 and plus 4. Z we can take 4 lambda minus 2 plus 10 is equal to 0. Right, now this is a linear equation in lambda, and we can solve this linear equation. Right, so we have 4 lambda plus 12, here we have 9 lambda plus 15, then we have 16 lambda minus 8 plus 10 is equal to 0. 4 lambda, 9 lambda and 16 lambda, so this is 25 plus 4, 29 lambda, and 12 plus 15 is 27, and 10 minus 8 is equal to 2. Right, so we have 29 lambda plus 29 is equal to 0. 29 lambda equal to minus 29, lambda is equal to minus 29 over 29, that is minus 1. So therefore the value of lambda is equal to minus 1. So now we can substitute the value of this lambda equal to minus 1 in these three expressions to get the value of x, y and z. So here we have 2 times minus 1 plus 6, here we have minus 3 times minus 1 minus 5, and here we have 4 times minus 1 minus 2, and this is minus 2 plus 6, that is 4, and this is minus minus plus, so 3 minus 5 is minus 2, and here minus 4 minus 2 is minus 6. Right, so the coordinates of this point M are now given by 4, minus 2 and minus 6. Right, so now here we have obtained the coordinates of this point M, which is the foot of the perpendicular drawn from this point P to the plane pi. Right, okay, now we have to find out the image of this point P, that is Q, and we have to get the value of alpha, beta and gamma. Right, now we know that since this image Q this is the image of this point P, hence Q is equidistant, that is PM must be equal to MQ. Right, so now we have here P, which is 6 comma minus 5 minus 2. Here we have M, that is 4 minus 2 minus 6, and here we have Q, that is alpha, beta and gamma. Right, now this point M is equidistant from this point P and Q, because Q is the image of this point P, and this plane pi acts as a mirror. Right, so now here we can utilize the concept of midpoint. Right, so the midpoint formula, it reads like this, that is, if this is x1 y1 z1, this is x2 y2 z2, and this is x y z, then we know that x is equal to x1 plus x2 over 2, y is y1 plus y2 over 2, and z is equal to z1 plus z2 over 2. Right, so now we have three equations. So now for x we have here 4, and x1 is 6, x2 is alpha over 2. Right, and for y we have here minus 2, and here y1 is minus 5 plus y2 is beta over 2. Right, and here for z we have minus 6, and z1 is minus 2 plus z2 is gamma over 2, right? So now here we have three equations in alpha, beta and gamma. Now we can solve these three equations to get the value of alpha, beta and gamma. So from here we have 6 plus alpha is equal to 8. From here we have minus 5 plus beta is equal to minus 4. And from here we have minus 2 plus gamma is equal to minus 12. Right? So now from here alpha is 8 minus 6, that is 2, and from here beta is minus 4 plus 5, that is 1, and from here gamma is equal to minus 12 plus 2, that is minus 10. Right? So we have alpha is equal to 2, beta is 1, and gamma is minus 10. So therefore the image of this point P has the coordinates 2, comma 1, comma minus 10, right? So the image of 6 minus 5 minus 2 is 2, 1 and minus 10 with respect to this plane, right? So viewers, this is how we solved this problem. So in this problem we had a point P and the foot of the perpendicular, that is PM, and the foot is M, and the coordinates of this point M are 4, minus 2, minus 6, and the image of this point P is Q, which has the coordinates 2, comma 1, comma minus 10, right?